The A320 overhead panel has nearly 300 individual buttons, switches, and circuit breakers. To cover it all properly, we're splitting it into two videos. In this first part, we'll go through half and explain what each button and switch does in detail. Now let's dive in. Welcome back to A320 Knowledge, your trusted source for Airbus expertise. Today, we're diving into part one of the entire overhead panel. First section is the wiper panel for CM1. Each windshield is provided with two-speed electric wipers that are controlled by their individual wiper selectors. With the wiper in the off position, the wiper is stowed out of view at the base of the window. When in the slow position, the wiper operates at low speed, and when in the fast position, the wiper operates at high speed. There is a speed limit of 230 knots to prevent damage to the motor. A rain repellent system is installed, but this is deactivated by some airlines, so check your specific manuals in your operation. When the rain repellent button is pushed, the timer applies a measured quantity of rain repellent to the applicable windshield. To repeat the cycle, the push button must be pushed again. This function is inhibited when the aircraft is on the ground and the engines are not running. The next section is the calls panel. This panel allows the flight deck to initiate calls to the flight attendants via the cabin interphone system and the ground crew via the flight interphone system. The cabin interphone system is used for communication between the cockpit, flight attendant stations, and other external locations on the aircraft. The flight interphone system is used for communication between the cockpit and the external service interphone panel, located near the nose gear on the external power panel. When the mech push button is pressed, the cockpit call light will illuminate on the external power panel, and an external horn will sound. When the button is released, the horn is silenced. The cockpit call light will remain illuminated until the reset switch located on the external power panel is pushed. The forward and aft push buttons will call the forward or rear sections of the cabin respectively. The all push button will call both the forward and aft sections of the cabin. When these calls are made, the following indications are observed in the cabin. 1. A pink light will illuminate at the corresponding flight attendant area call panel. 2. A captain call message will appear on the corresponding flight attendant indication panel. 3. A high-low chime will sound through the corresponding cabin loudspeaker. Voice communication is established between the flight attendant station and the flight deck when the flight attendant picks up the handset. The final button on the calls panel is the emergency call button. When this is pressed, 1. The on and call light will flash on the push button. 2. Two pink lights will flash at all flight attendant area call panels. 3. An emergency call message appears on all flight attendant indication panels. 4. A high-low chime sounds through all loudspeakers. These calls will be reset when the flight attendant presses their reset switch. The emergency call is reset by turning the push button off. The next section is the oxygen panel. This has some simple controls for both the passenger oxygen system as well as the flight deck oxygen. The red-guarded Mask Man On push button in its default automatic position will deploy the cabin oxygen mask doors automatically when the cabin altitude exceeds 14,000 feet. In this case, it will also play a pre-recorded message to the cabin. When the push button is manually pressed, the cabin oxygen mask doors will open regardless of cabin altitude. In this case, no pre-recorded message will be played. In an emergency decompression scenario, the ECAM QRH will still call for the push button to press even if the masks have automatically deployed. As with any guarded push button, the action of switching this on must be confirmed between the two pilots. And for the case of a red push button, this action is irreversible. The passenger system on indication is not a push button. The message "System On" illuminates in white when the oxygen mask doors are actuated. It remains on until the oxygen timer reset switch is pushed on the overhead maintenance panel. Chemical generators supply passenger oxygen for approximately 15 minutes. The crew supply push button controls the flight deck oxygen system. When in the off position, the off light illuminates white and the oxygen supply valve is manually closed. When the push button is selected on, the off light extinguishes and the cockpit oxygen supply valve is open. Low pressure oxygen is supplied to the masks. Pre-flight checks of the minimum oxygen pressure on the door SD page. The values for your operator can be found in your FCOM. The voice recorder panel consists of cockpit voice recorder, CVR, and digital flight data recorder, DFDR controls. The CVR and DFDR are energized automatically during the following conditions: on the ground for 5 minutes following electrical power, on the ground continuously with at least one engine running, continuously in flight, regardless if engines are operating. The CVR and DFDR both automatically stop 5 minutes after the last engine is shut down. The cockpit voice recorder is located in the aft section of the aircraft, equipped with an underwater locating beacon. It records direct conversations between crew members through a cockpit area microphone and boom microphones, oral cockpit warnings, intercommunication, and radio transmissions. The CVRs are capable of 25 hours of recording. The passenger address system is also recorded if a PA reception knob is selected on. When the ground control push button is selected on, the CVR and DFDR are energized. This is used to test the CVR and DFDR and to record outside the normal recording scenarios. The push button reverts back to automatic after engine start. When the CVR erase push button is pressed for 2 seconds, it erases the CVR tape, provided the airplane is on the ground and the parking brake is set. When the CVR test push button is pressed and held, the CVR test is activated, provided the ground control is on and the parking brake is set. During the test, a low-frequency tone is heard through the cockpit loudspeakers. Ground Proximity Warning System Panel. There are 2 systems controlled by this panel: the basic GPWS and the enhanced GPWS, known as eGPWS. In another video, we will go over the GPWS system in detail. This tutorial will simply cover the functions of the GPWS push buttons. The terrain push button on the left-hand side controls the eGPWS. An amber fault light illuminates along with an ECAM caution if the terrain awareness display or terrain clearance floor functions fail. By pressing this push button off, all eGPWS functions are disabled, and an ECAM caution NAV GPWS terrain detection fault is displayed. The 4 push buttons to the right of this are connected to the basic GPWS. The system push button controls the entire basic GPWS system. By pressing this push button off, modes 1 to 5 are inhibited, which disables all warnings. This might be useful for a gear-up landing. An amber fault light will illuminate, along with an ECAM caution, in the event of a GPWS mode 1 to 5 malfunction. When the glide slope mode push button is set to off, the mode 5 glide slope warning is inhibited. This could potentially be used for a localizer-only or localizer back-course approach. When the flap mode push button is set to off, the mode 4 too low flaps warning is inhibited. This could potentially be used if the flaps are unable to extend or when doing a flap 0, 1, or 2 landing. The landing flap 3 push button is set to on when a flap 3 landing is being conducted. In this case, the mode 4 too low flaps warning is inhibited. GPWS flap 3 is also displayed on the ECAM memo. Next is the emergency electrical power panel. The black guarded emergency generator test push button connects the relevant buses to the emergency generator when pressed and held. This test is normally performed by maintenance and tests the emergency generator, utilizing the blue hydraulic system, but without deploying the RAT. If the normal AC buses are supplied, then the emergency generator is driven hydraulically if the blue electric pump is running. The AC essential bus and the DC essential bus are then connected to the emergency generator. Note, the DC essential shed and AC essential shed buses are not powered in this case. ECAM then displays the electric page automatically, although this is only true on the ground. Now, if the batteries are the only power supplying the aircraft, then the static inverter powers the AC essential bus only. The generator one-line push button is part of the smoke drill procedure. In order to isolate the cause of electrical smoke, the flight crew manually extends the rat and enters the emergency electrical configuration by turning the main generators off. This deactivates all non-essential electrical equipment. By turning this push button off, the generator one line contactor opens and generator 1 becomes isolated from the electrical system, except for powering one wing tank fuel pump per wing directly. The AC bus 1 channel is now supplied from generator 2 through bus tie contactors. If an amber smoke light illuminates, then smoke has been detected in the avionics ventilation duct. The rat and emergency generator fault light illuminates red if the emergency generator is not supplying power when AC bus 1 and AC bus 2 are not powered. In older aircraft, a logic also requires the nose wheel landing gear to be up and retracted. The alert is normally triggered when a malfunction has caused the rat to not automatically deploy. In this case, manually extending the rat may be required. When pressing the red guarded man-on push button, this selects a manual rat extension. This normally takes 5 seconds to extend. The emergency generator coupling occurs approximately 3 seconds after the rat is extended and supplying the emergency generator. As soon as the emergency generator electrical parameters are within tolerance, the emergency generator is connected to the aircraft network. The rat automatically deploys when the following conditions are met. 1. AC bus 1 and 2 are not electrically supplied. 2. Aircraft speed exceeds 100 knots. Remember, when pressing a red guarded push button, the action must be confirmed between both pilots, and the action is irreversible. Next is the evacuation panel. The emergency evacuation signal system alerts the flight attendants to evacuate the cabin. The command switch activates the evacuation alert from the flight deck. The evac light flashes red, and the evacuation horn sounds in the flight deck and cabin. Pushing the command switch a second time cancels the evacuation alert in the flight deck and the cabin. Some airlines do not utilize the command push button and simply rely on an oral announcement from the evacuation initiator, so check your operator's SOPs. The horn shut-off push button silences the evacuation horn in the flight deck after the command button has been pressed. Captain and purser switch allows the flight crew to select whether the flight attendants are able to initiate an evacuation. This is normally dictated by company standard operating procedures. When the switch is in the captain and purser position, the evacuation alert may be activated from the cabin or flight deck. When the evacuation switch is selected to captain, the evacuation alert may be activated only by the flight deck. In case of a cabin-initiated evacuation, a guarded command push button is located at each flight attendant panel. The flight control panel consists of a portion of the primary flight control computers, ELAC-1, SEC-1, and FAC-1. The remaining computers are located on the right-hand side of the overhead panel. The associated flight control computer is engaged when the lights are extinguished. When a push button is set to off, the respective computer is turned off, and its functions are either lost or picked up by another computer. A fault light illuminates when a computer failure is detected or during the computer's power-up test, which lasts for approximately 8 seconds. This test occurs for each flight control computer upon electrical power application or after an electrical transient interruption. The fault light extinguishes when off is selected or at the completion of a satisfactory power-up test. A computer can be reset by turning it off, then on. Next is the ADIRS panel. The Air Data Inertial Reference System consists of 3 identical Air Data Inertial Reference Units. Each ADIRU combines an Air Data Reference (ADR) system with a Laser Gyro Inertial Reference (IR) system in a single unit. The ADR provides barometric altitude, airspeed, Mach number, angle of attack, temperature, and overspeed warnings. The IR provides attitude, flight path vector, heading, track, acceleration, vertical speed, ground speed, and aircraft position. The IR provides an inertial position input to the FMGCs for navigation computations. ADIRU 1 and 2 supply their on-side systems. ADIRU 3 is a hot spare in case of failure. To initiate a full alignment, the ADIRS switch on the overhead panel is set from the off position to the nav position. The selector should be turned to nav in the order of 1, 2, and then 3. A fast align of the ADIRS can be achieved by selecting all 3 of the ADIRS switches to off, then back to nav within 5 seconds. At the beginning of the alignment, a test is performed to see whether the batteries can power the ADIRS. This is displayed via the amber on-bat light at the top of the panel. If one or more of the ADIRS are running on battery power, on-bat will display constantly. The on-bat light does not come on in the case of a fast alignment. IR1, 2, and 3, as well as ADR1, 2, and 3 can be turned off using the corresponding push button. A steady fault on the IR push buttons indicates a total IRU failure, whereby attitude and heading are not recoverable. A flashing fault on the IR push buttons indicates a partial IRU failure, whereby attitude and heading may be recoverable. In this case, the ADIRS switch can be moved to the AT position to retain the attitude and heading data only. The heading data must be entered using the MCDU. This must be updated frequently, roughly every 10 minutes. If the ADIRS switch is set from nav to AT or nav to off during flight, nav mode will be inoperable for the remainder of the flight. In the case of an ADR1 failure, predictive GPWS functions are lost. In the case of an ADR2 failure, both baroreference channels are driven by the same FCU channel. The loss of 2 ADRs will result in the aircraft being placed into alternate law. In the case of an ADR1 plus 3 failure specifically, the loss of the landing gear safety valve occurs. This means a gravity gear extension is necessary. This is not covered by the ECAM. In the case of an ADR1 plus 2 plus 3 fault, ADIRS 1 remains on battery until electrical power is restored, whilst ADIRS 2 and 3 remain on battery for only 5 minutes. In this scenario, the backup speed scale is introduced below flight level 250. Its speed scale is based on angle of attack data and altitude is based on GPS data. Above the ADIRS panel is the PA and cockpit door video panel. The PA indication is not a push button. It illuminates when the PA is being conducted from either the flight deck or the cabin, including pre-recorded announcements. The cockpit door video push button can be set to off to manually turn off the power for the cockpit door surveillance system. The cockpit door panel is located at the uppermost part of the overhead panel near the circuit breakers. The strike lights indicate the status of the 3 locking latches. When the lights are off, it indicates the locking latches are operative. When the lights are on, it indicates the locking latches are faulty. Rapid pressure variation in the cockpit is detected by 2 redundant differential pressure sensors. This allows simultaneous opening of all latches when a certain pressure drop is detected. The pressure sensor lights indicate the status of the 2 pressure sensors. When the lights are off, it indicates the sensors are operating normally. When the lights are on, it indicates the sensors are faulty. The emergency locator transmitter, ELT, is mounted in the back of the aircraft and is designed to be triggered upon impact or may be manually activated using the remote switch and control panel indicator in the cockpit. An audio alert starts and a distress signal is transmitted for search and rescue upon activation. The distress signal is only audible when the correct frequency is selected in the RMP and the corresponding reception knobs of the ACP are set accordingly. An additional handheld ELT is usually mounted in the cockpit as well. On the red guarded switch, selecting on will transmit an emergency signal on the ELT. When in armed mode, the ELT transmits an emergency signal in the case of impact on 3 frequencies. When the on light is illuminated amber, the ELT is transmitting or is in automatic test mode. If the ELT is transmitting when the aircraft is on ground, the external horn sounds. When the ELT is transmitting, the light flashes every 5 seconds. After a reset, the light flashes every second before stopping. If the test reset push button is held for 2 seconds, the ELT stops transmitting. If held for 10 seconds, the ELT starts an automatic test. If the ELT is unduly triggered while in armed mode, for example, due to a hard landing, hold the test reset position for 2 seconds to reset the ELT and stop the signal. The strobe switch is used to turn on and off the high-powered white flashing strobes. There is one on each wingtip and one below the tail cone. The strobes are normally switched on when entering an active runway, either for takeoff or for crossing one runway to get to another. They should be kept on whilst airborne. In the off position, the strobes are always off. A strobe light off ECAM memo is displayed in green if the strobe switch is left off in flight. When the switch is in the auto position, the strobes remain off whilst on the ground and then automatically turn on when the main gear strut is not compressed, i.e. when in flight. When the switch is set to on, the strobe's lights flash continuously both on the ground and in the air. On newer aircraft, a blue LED light below each strobe light flashes if the strobe light is coming to the end of its life and requires replacing. Next is the beacon. This switch controls the 2 flashing red lights, one on top and one on the bottom of the fuselage. This signals the ground crew and other aircraft that the engines are about to start or still running. This is a simple on and off switch. The wing switch controls 2 beam lights on each side of the fuselage. These lights provide lighting on the wing leading edge and on the engine air intake to detect ice accretion. This is a simple on and off switch. This switch controls both the navigation and logo lights. The navigation lights are situated on each wing tip and in the APU tail cone. The logo lights are installed in the upper surface of each horizontal stabilizer to illuminate the company logo on the vertical stabilizer, provided the main gear struts are compressed or the flaps slats are extended. This switch is normally turned on during the preliminary cockpit preparation, and especially before the exterior walk-around to check their serviceability. When in the off position, all of the navigation and logo lights are off. In position 1, the logo lights and the first set of navigation lights are turned on. In position 2, the logo lights and the second set of navigation lights are turned on. Position 2 is normally used when some of the position 1 lights are unserviceable. The runway turn-off switch controls 2 lights situated on the nose landing gear assembly. They are angled at 45 degrees. Some airlines use this when entering a runway, whilst some airline SOPs mandate it for taxi. Check your company manuals for your operating procedures. These lights will also turn off automatically when landing gear is retracted. The 2 landing light switches allow you to operate the right and left landing lights independently. They are situated on the underwing surface. The LDG-LT ECAM memo is displayed in green if one landing light is extended. Some airline SOPs only allow these to be extended below 250 knots. This is because they protrude outwards from the wing and act as a small secondary drag device for the aircraft. They are normally retracted after slat retraction on departure and extended at landing gear extension on approach. However, these are regularly utilized below 10,000 feet for both departure and approach. When in the retracted position, they are switched off and stowed. In the off position, they are switched off but are in the extended position. When selected on, they are both switched on and extended. The nose switch controls the taxi and takeoff lights. These 2 lights are attached to the nose gear strut and turn off automatically when the landing gear is retracted. As the name suggests, the taxi light is used for taxiing, and the takeoff lights are used when cleared for takeoff. In the off position, both lights are off. In the taxi position, the taxi light turns on. In the takeoff position, both the taxi and takeoff lights are turned on. The APU master switch controls the APU operation and its starting and shutdown sequences. When in its off lights out condition, the APU is off, or APU is in its manual shutdown sequence. When the switch is on, the APU is running, or in its starting sequence. When the master switch shows an amber fault light, an automatic shutdown of the APU has occurred. This can be due to many reasons. The APU start switch initiates the starting sequence of the APU. When in its off lights out condition, the APU is off. When pressed, the push button initially lights up its on light. This means the APU start sequence is in progress. The exact start sequence will be detailed in another video. 2 seconds after the N% reaches 95%, or when the N% is above 99.5%, the on light extinguishes and the green available light illuminates. The APU available ECAM memo also appears in this case to signify that the APU is available for use and can supply bleed air and electrical power to the aircraft systems. Next up is the signs panel. The seatbelt switch controls the fasten seatbelt and return to seat signs in the cabin. A low-tone chime is also played when the switch is moved either way. When the seatbelt switch is on, the seatbelt's ECAM memo is displayed. This is a simple on and off switch. The switch next to the seatbelts can be one of 3 switch variants, which are 1. No smoking, 2. Exit, and 3. No portable electrical devices. The no smoking switch is most commonly found, so we will focus on that. It has 3 positions. In the off position, the exit and no smoking signs are turned off in the cabin. In the auto position, the exit and no smoking signs are turned on in the cabin when either the landing gear is extended or the flaps or slats are extended. When in the on position, the exit and no smoking signs are always illuminated. For aircraft in the non-smoker configuration, the no smoking signs are always on. The no smoking ECAM memo is displayed whenever the signs are on. If the cabin altitude goes above 11,300 feet, plus or minus 350 feet, the cabin lights and all of the cabin signs, except for the no portable electrical devices sign, turn on regardless of switch position. Lastly, the emergency exit lighting switch. This controls the floor proximity marking system, the exit signs, and the overhead emergency lights. When the switch is in the on position, all of the above lighting illuminates. In the off position, all of the lights are off, and the amber off sign illuminates next to the switch. Leaving the switch in the off position when the aircraft is shut down allows certain components of the emergency lighting system to charge. When in the arm position, certain components illuminate in certain scenarios. If the normal aircraft electrical power system fails or the DC essential shed bus fails, all 3 of the emergency exit lighting components will illuminate. In the case of an AC bus 1 fault or is unpowered, the overhead emergency lighting will illuminate. It is now powered by the DC essential shed bus. If this then subsequently fails, then dedicated battery packs will power this lighting for approximately 12 minutes. Finally, we move on to the internal lighting panel. The overhead integral lighting knob turns the overhead panel's integral lighting on and off and adjusts its brightness. The ice indicator and standby compass switch turns the standby compass light and the external visual ice indicator light on and off. The dome switch controls both dome lights in the flight deck on the overhead panel above the circuit breakers, with dim and bright light settings. The annunciator light switch controls all the flight deck annunciator lights. In the test position, all flight deck annunciator lights turn on, including the LCDs on the FCU. In the dim position, the brightness of all flight deck annunciator lights is reduced. In the bright position, the brightness of all flight deck annunciator lights is at their normal level. The wing push button controls the activation of the wing anti-ice valves. When the push button is pressed and the valves have fully opened, a blue on light appears. The control valves open if a pneumatic supply is available. If the aircraft is on the ground when the wing push button is pressed, it will remain open for approximately 30 seconds for a self-test. After this, it will then close until airborne. In flight, hot air from the pneumatic system heats up the 3 outboard slats, slats 3, 4, and 5 on each wing. The air is supplied through 1 valve in each wing. When the wing anti-ice is selected on, the wing anti-ice ECAM memo appears in green. Also, both engines' N1 limits automatically reduce, and their idle N1s automatically increase to cope with the bleed demand. On NEO aircraft, when the thrust levers are in either the toga or flex MCT detent with the push button on, WAI appears at the top of the EWD above the engine N1%. The push button is generally turned on if visible icing is noticed on the external ice indicator or on the windshield wipers. And some FCTMs suggest that the wing anti-ice should only be used after thrust reduction altitude on takeoff and be turned off before the final approach fix on approach. As always, consult your manuals and apply airmanship where necessary. If a pneumatic bleed leak is detected or the electrical supply is lost, the wing anti-ice valves will automatically close. A point to note, the APU bleed should not be used in conjunction with the wing anti-ice due to the bleed architecture. An amber fault light appears on the wing push button when either a low pressure is detected or the position of the anti-icing control valve is not in the required position. This is accompanied by an ECAM caution. Note, the amber fault light does appear briefly when the valves are in transit, so this can be expected when the push button is initially turned on. Next is the engine anti-ice push buttons. There is one for each engine. These are generally switched on when expecting to be in icing conditions. And icing conditions exist below 10 degrees C, either on the ground or in flight, and when any form of visible moisture is present, except during the climb and cruise when the static air temperature is below -40 degrees C. There are some subtle differences depending on whether the engine is a CEO or NEO type. In both cases, each engine has its own anti-ice system, with an independent hot bleed air source, which comes from the high-pressure compressor stage of the engine and protects the engine nacelle from icing. On both variants, the valves are electrically controlled and pneumatically actuated. In a similar fashion to the wing anti-ice, when the engine push buttons are pressed and the valves have fully opened, a blue on light appears. When the engine anti-ice is selected on, the engine anti-ice ECAM memo appears in green. Also, both engines' N1 limits automatically reduce and their idle N1s automatically increase to cope with the bleed demand. On NEO aircraft, when the thrust levers are in either the TOGA or Flex MCT detent with the push button on, EAI appears at the top of the EWD above the engine N1%. Finally, once the valves are opened, continuous ignition will be selected for that engine, and the ignition memo appears on the ECAM for some variants. On CEO aircraft, the engine anti-ice push button controls a single anti-ice valve for each engine. If the air is unavailable, for example if the engine is not running, the valve will automatically close. The valve will automatically open when either the electrical supply is lost to the engine, a bleed leak is detected, or when ignition start is selected on the engine mode selector, provided the engine is already running. If an amber fault light appears on a CEO aircraft, then the valve position disagrees with the push button selection. Note, the amber fault light does appear briefly when the valves are in transit, in the same way as the wing push button, so this can be expected when the push button is initially turned on. On NEO aircraft, the single anti-ice valve is replaced by two pressure-regulated and shut-off valves, which enable the flow of bleed air to the engine's air intake inlet. On NEO aircraft, only one of the pressure-regulated and shut-off valves are performing the shut-off function when the engine anti-ice is off. Continuous monitoring of the system enables the detection of bleed air duct leaks or bursts and deactivation of the system. In the case of a detected burst duct, both valves are commanded closed. And in the case of an electrical failure, both valves are fail-safe opened, providing the air inlet with enough pressure for the anti-ice to function. If an amber fault light appears on a NEO aircraft, then the valve position disagrees with the push-button selection and is associated with an array of anti-ice ECAMs. These will either be a valve closed, valve open, control fault, or overpressure caution. With any anti-ice fault, if it fails to open, avoiding icing conditions should be a priority. And if it fails to close, then a fuel penalty factor now applies. Next is the probe and window heat push button. The aircraft uses electrical heating to anti-ice each windshield, defog the cockpit side windows, and heat the external probes. When the probe and window heat push button is in its automatic lights out position on the ground, the three pitot probes and both sides of the windshield are heated on a low power setting, provided at least one engine is running. The TAT probes are not heated in this case. Once airborne, all probes and windows are heated on a high power setting. Only one heating level exists for the cockpit side windows. The window heating is controlled by two window heating computers, one for each side. There are three probe heat computers, one for the captains, first officers, and the standby probes. These computers automatically regulate their systems, protect against any overheating, and indicate faults. If one of the window heat or probe heat computers fail, the remaining ones do not replace it. Note, there is no fault light indication on the probe and window heat push button. When the push button is pressed, the blue on light appears and all probes and windows are heated permanently, regardless of whether the aircraft is airborne. The push button is regularly used for ground operations in cold weather conditions and can be found in the related FCOM supplementary procedure. Note, care must be taken to ensure that all relevant covers have been removed from any probes before selecting the push button on. Also, if the push button is selected on with ice or snow accumulation on the windshield and/or the upper cockpit fuselage, then melted ice or snow may run down from these areas and can refreeze on the fuselage area below if the temperature is very cold. This can create ice buildup, known as ice ridges, on the forward fuselage that can disturb the airflow around the static, pitot, and angle of attack probes. The pack flow selector. This controls the flow rate of air through the pack valve and is controlled by the ACSC. It is adjusted according to the number of passengers and the ambient conditions. If there is a low passenger load, then the pack flow selector should be in the low position. The exact passenger number is airline and aircraft variant dependent, so consult your FCOM for this particular number. When in the low position, the flow rate is 80% of the normal flow rate. This results in less bleed air demand and therefore increases the fuel efficiency. If low is selected, the pack flow can automatically provide up to the normal flow rate if the cooling demand cannot be satisfied. The pack flow selector is in the normal position when in standard operations. This commands 100% of the normal flow rate, except for when the aircraft is on the ground with both engines running, whereby the normal flow rate is limited to 85%. When in the normal position, the actual flow rate will be either normal or high, depending on the bleed air demand. The pack flow is selected to the high position when in very hot or humid conditions, or for smoke removal purposes. This commands 120% of the normal pack flow rate. If the APU is supplying the bleed air, or there is a single pack running the entire system, then the pack flow automatically reverts to high, regardless of the selector position. Next is the pack push buttons. Both push buttons control a pack flow control valve via their respective ACSCs. The pack 1 push button controls the pack flow control valve via ACSC 1, and the pack 2 push button controls the pack flow control valve via ACSC 2. The valve is pneumatically operated and electrically controlled. When the push button is in its default lights out position, the pack is on and the pack flow control valve is automatically controlled. This will provide air conditioning to the aircraft, providing there is a bleed air source, i.e. the APU or engines are running. On NEO aircraft, packs will appear on the EWD when the packs are switched on and the thrust levers are in either the TOGA or Flex MCT detent. When the push button is in the off position, the respective pack flow control valve closes. If there is no air pressure, a spring will automatically keep the valve shut. The pack flow control valves will automatically close, even if selected on, in the following scenarios. 1. When there is low pneumatic pressure upstream of the packs. 2. When there is a compressor outlet pack overheat greater than 260 degrees C. 3. When the engine fire push button is pushed on the related side. 4. When the ditching push button is pressed. And finally 5. When the engines are being started. Note, if the crossbleed valve is open during the engine start, both pack flow control valves close. If the crossbleed valve is closed, then the valve located on the starting engine side immediately closes when the engine mode selector is set to ignition start. It remains closed on the starting engine side, provided that the engine master lever is still on, the start valve is open, and the engine N2 is less than 50%. The reopening of the pack flow control valves on the ground is delayed for 30 seconds for CEO aircraft and 60 seconds for NEO aircraft to avoid a supplementary pack closure cycle during the second engine start. An amber fault light and ECAM caution appears if the pack flow control valve position disagrees with the selected position, or in the case of a compressor outlet overheat or pack outlet overheat. Next is the zone temperature selectors. There is one selector for each of the following: the cockpit, the forward cabin, and the aft cabin. Each selector has a range from cold to hot. In the cold position, the zone temperature aims to achieve 18 degrees Celsius or 64 degrees Fahrenheit. In the hot position, the zone temperature aims to achieve 30 degrees Celsius or 86 degrees Fahrenheit. In the middle 12 o'clock position, the zone temperature aims to achieve 24 degrees Celsius or 76 degrees Fahrenheit. The forward attendant panel allows the cabin crew to modify each cabin zone temperature by plus or minus 2.5 degrees C. Next is the engine bleed push buttons. These control the position of the engine bleed valves, which tap engine bleed air from the IP or HP sections of the compressor, depending on pressure and temperature levels. When the push button is in its default lights out position, the valves are open. Even with the push button in the on position, the valves pneumatically close if the upstream pressure drops below 8 psi for CEO aircraft or 15 psi for NEO aircraft, or if there is return airflow. In addition to this, the valves will electrically close automatically in the following scenarios. 1. When the APU bleed valve is open via the APU bleed push button. 2. When an engine fire push button is pressed on the respective side. 3. When the BMC senses either a leak, engine start, overheat, or overpressure. And 4. If no bleed consumers, such as packs or wing anti-ice, are in use on the respective side. When the push button is in the off position, the bleed valve, the fan air valve, and the HP valve all close. An amber fault light and an ECAM caution appear in any of the following scenarios: an overpressure downstream of the valve, a bleed air overheat, a wing or pylon leak, the bleed valve remaining open during engine start or while the APU bleed is on, the HP valve failing to open on the ground, or a dual bleed temperature sensor failure. Additional failure scenarios specific to NEO aircraft include a single bleed temperature sensor failure or disagreement on the ground, and a fan duct burst detected by the FADEC. Next is the ram air push button. This is a black guarded push button, meaning it must be confirmed by both crew members before pushing, but the action can be reversed if necessary. It is used for smoke removal scenarios or if both packs fail. In its default lights out position, the ram air inlet is closed. If the push button is pressed, the on light appears. If the differential pressure is less than 1 psi and the ditching push button is in its normal position, then the outflow valve opens to approximately 50%. Emergency ram airflow is then supplied directly to the mixing unit. Note, this is only applicable if the outflow valve is under automatic control. If it is under manual control, it will not automatically open. If the differential pressure is greater than or equal to 1 psi, the outflow valve control remains normal and no emergency ram airflow will be supplied. Next is the APU bleed push button. In its default lights out position, the APU bleed valve is closed. If selected on, the blue on light appears. The APU bleed valve will open if the APU N percentage is greater than 95% and there is no leak detected in the APU or the left-hand side of the bleed system. Note, if there is a leak on the right-hand side of the bleed system, the cross-bleed valve automatically closes. The APU bleed ECAM memo appears if the APU is available and the APU push button is selected on. The APU bleed can be used to supply the entire air conditioning system and to start either engine. Some further notes on the APU bleed. It should not be switched on in conjunction with the wing anti-ice, and in some SOPs, it is recommended to switch the APU bleed on before shutting the engines down on stand to minimize any odors from the engine exhaust fumes entering the air conditioning system. Next up is the crossbleed selector. This electrically controls the position of the crossbleed valve using two electric motors. one for automatic mode and one for manual mode. It is normally set to the auto position. In automatic mode, the cross-bleed valve is open if the APU bleed valve is open. It is closed if the APU bleed valve is closed, or in the case of a wing, pylon, or APU leak, except during engine start. The cross-bleed valve allows the air supply systems of the two engines to be isolated or interconnected and helps prevent cavitation in the hydraulic reservoirs. When the selector is in the open position, the cross-bleed valve opens, which is used for a cross-bleed engine start as described in the FCOM. When the selector is in the shut position, the cross-bleed valve is manually closed. For bleed management following an engine failure where a fire push button is pressed, do not open the cross-bleed valve, even if the ECAM erroneously commands you to. Instead, consider utilizing the APU bleed. The APU bleed can only be used if engine 1's fire push button has not been pressed and the cross-bleed selector is set to shut to ensure the APU bleed can supply the air conditioning system without contaminated air. The final button on the air conditioning panel is the hot air push button. This controls the hot air pressure regulating valve, which is pneumatically operated and electrically controlled. It regulates the hot air pressure in the air conditioning system and is controlled by ACSC1. If no air pressure is present, a spring keeps the valve shut. In its default lights out position, the valve regulates the hot air pressure. When in the off position, the hot air pressure regulating valve and the trim air valves all close, and the fault circuit is also reset. The valve automatically closes when either both lanes of an ACSC fail, a duct overheat above 88 degrees Celsius occurs, or at least two trim air valves fail. In the case of a duct overheat, an amber fault light appears alongside an associated ECAM caution. The valve and trim air valves will automatically close in this case. The fault light is removed when the temperature drops below 70 degrees Celsius and the flight crew has selected the push button off. Our popular A320 tech quizzes are now part of an exclusive newsletter membership designed to provide you with even more value. As a member, you'll receive 4 brand new A320 tech quizzes every month, one each Monday, delivered straight to your inbox. You'll also receive exclusive deep dives into A320 systems, procedures, and techniques that go beyond this YouTube content. And you'll also gain access to bonus content and other surprises to keep your knowledge fresh and up to date. If you're interested, click the link in the description or scan the QR code on screen to sign up today. Thanks for tuning in, and let's take your A320 knowledge to the next level.